All right, so really quick, just to review what we did last time. If I put a 10 in the decimal section, folks, how would you write 10 as a percentage? A 1,000, yes. So remember, what do you do to go from decimal to percent? Move essentially the decimal 2 to the right, or you multiply by 100. What's 10 times 100? 1,000, okay? And just to be safe, how do you write 10 as a fraction? Yeah, you can, if you want, just write 10. That's the mixed fraction format. If you want to write it as an improper fraction, that's okay too. Either of those I would accept, it's okay. Right? The cool thing about just writing 10 is that it's a nice cheeky answer. Right? You don't even have to change anything because it's the same thing. Alright? Now let's see. So I found a savings account out there, folks, that will pay me 3 1/5% interest rate, which is really good right now. You can find over 3%, that's a good deal. 3 1/5%. How do you write that as a decimal? 0.032. Please be careful with this one. What I get a lot of times happening on student homeworks and student test problems is they look at this problem and say 3 1/5%, and they say, oh great, I know 1/5, it's 0.2. Therefore this is 3.2, and they'll write down the number 3.2. You're not wrong, it's not 3.2 is the correct percentage, but don't forget that you still have to convert that percentage back into a decimal. So 0.032, and how do you convert that number into a fraction? How would you read that number correctly? 32 1,000ths. So what should I write? 32 1,000ths, right? And hopefully you won't leave it like that. So what will you do with 32 1,000ths? Reduce. And what will you reduce it to? So you can do it one at a time, folks. There's nothing wrong with doing it one at a time, right? You can go to 16 over 500. Am I done yet? No, they're still both even. What's next? 8 over 250, right? Just keep cutting things in half. Can I cut them in half again? Keep going. Can I cut them in half again? Can I cut 125 in half and do it evenly? No. Okay, so there's your stopping point, okay? If you could do this in one step by dividing top and bottom by 8, that's fine. Nothing wrong with it. But if you have to, do it. I mean, it's easy to cut things in half, folks. So just keep doing it until you can't anymore. That's okay. And remember that from now on, every test that you take, you get to use your calculator 100% of the time. If you don't simplify a fraction when you get to use your calculator, shame on you. Okay? That's all there is to it. Just shame. I'm going to come into class and I'm going to go, and you're going to know what I mean when I do that. Okay? So don't write a fraction without completely simplifying it on a test. Okay? And honestly, even on a homework, even though sometimes the book tells you it's okay not to reduce the fraction, give the book a finger and just do it anyways. Alright. So last but not least, let's do one. Let's say the fraction is 1/6. How do you write that as a decimal? your calculator, so by all means, pull it out. What would you do? What'd you get?
0.16666667.
So what should I write?
167. No, repeating.
0.16 repeating. Why did it write a 7 at the end? Because it rounded. Technically, what's after that last 6? Another 6. And since that number's 5 or above, what does it do with the 6 before it? It rounds it up to 7. That's what calculators always do. That last number on a calculator is always rounded. Always. Okay? So, that's the decimal. How do you write that as percentage? Yeah. It's not like you do anything different, right? So you just move the decimal over 2. So what's left when you do that? Yeah, 16.6 repeating percent, right? Don't just write 16 because it only looks like there's 1 6 here, right, folks? You know that means there's a whole buttload of them, right? So how would you write that out the repeating decimal? What is 0.6 repeating, folks? 2/3, right? So how would I rewrite this so that there was no repeating decimal? Remember that all repeating decimals can be rewritten as fractions at some point in time. There's a representation out there somewhere. You can always do it. All right? All right, so again, this is just me quick review the stuff we did last time. Good? All right, so now let's actually start using this stuff. All right, so let's see. What was that? Oh, you should have your test, right?
Yeah, I have them.
You can have them if you want them. Yeah, that's cool. What is, say, 25% of 40? All right, so what is 25% of 40, folks? When you do these problems, when it's a nice little one-sentence problem, there are 2 techniques that you can use. One technique is to use the proportion method to solve it, where you use is over of equals percent over 100. The other technique that I try to show students is the translate method. Okay, so those are 2 standard techniques you can use to solve one-sentence percentage problems. All right? So, the idea, this side, folks, when you are doing is over of equals percent over 100, the concept is when you start the problem, you always start the problem with a fraction equals a fraction. And you automatically put the 100 in there, okay? When you go to fill in the other 3 spots, you're going to fill them in a specific order. Do the percent first. In other words, what number is in front of the percent sign, folks? 25. Put that where the percent sign is in this demonstration, right? 25 is over the 100. Fill in the number that's after the word of second, and always put it where the word of is. What number up there follows the word of? 40. Put it where the number 40 is. And then last but not least, do is last. What number is associated with the word is in my sentence? There will always be one of them that's an X. That's the whole point. You're going to be given 2 of the 3. You're either going to be given the is, the of, the percent. 2 of those 3, your job is to find the third one. That one will always be x. Okay? And when you have a proportion like this, folks, how do you solve it? Cross multiply and divide. This is exactly when you use cross multiply, and honestly, folks, it really should be the only time you use cross multiply and divide. Is when you have a fraction equals a fraction where there's only one variable floating around in the fraction. Okay? If you've used cross multiply in other situations, technically you're doing something else. They really should have called it something else, but I won't go down that road because it'll make me crazy. So, anyways, the idea, right, is that you cross multiply, right? 100x, and then cross multiply the other way equals 40 times 25, and then just solve for x, right? So 100x equals 1,000 divided by 100. X is 10. And so when you write it up there, 10 is 25% of 40, which should make sense. All right? That is one standard technique. All right? If you have used this method to solve percentages in your past, and you like it, by all means, continue to use it. Okay? It works perfectly fine. Just make sure that you fill the right spots in with the right numbers, and it will always work. Okay? Now, the translate method. I like this one because it's a little bit more algebra-based, and it's a little bit more traditional way of looking at algebra with percentages. So, what I do is I translate every word in the sentence. What should I write down when I see the word of what? X. Verbs, folks, always equal signs. 25%, when you are doing the translate method, folks, you will take your percentage and convert it to its decimal format. So 25%, what will I write it as? 0.25. And the reason why I like to do the translate method is because, folks, how do we translate the word of? Multiply. It's one of those things that gets into your brain that says, hey, every time you see the word of, think multiplication, and then translate 40 by writing the number 40 down, and then you just perform the operations to solve for x. All right? And again, it's a method of setting up some algebra and saying, hey, let's do some algebra. And nicely enough, folks, what is 0.25 times 40? 10. Same answer that we had a second ago. Okay? Whichever one you guys like better, great. Go for it. I am happy, again, if there are other techniques that you have been shown in your life and they always work, again, I'm not trying to force you to do these problems any one specific way, just giving you options. Okay? Alright, so let's try another one then. Let's try 40 is 30% of what? All right, so again, similar type of problem, but slightly different, okay? So, I'm always going to do these first few problems here, both techniques, just because I want you guys to try and get semi-comfortable with both of them just a little bit. All right? So, it is over of techniques, folks. Please remember for this next test you get a note card. This is the sort of thing that you might want to write down on the note card just so that you can remember it, just to be safe. Wouldn't necessarily be a bad idea. But, again, the technique when you are doing is over of, write the fractions down first with the 100 in the denominator of one side. It doesn't matter which side you put the 100 on, folks. Just remember that it always comes with the percent sign, okay? So, step 1, work with the percent. 30. Step 2, work with of. What number follows of? X. Go to is last. What number is associated with is? 40. And wherever x is, cross, multiply, and divide. Okay? So in this case, here's your cross multiplication, right? Depending on wherever x is. 40 times 100, divide by what's across from it. Divide by 30. Okay? That's the cross multiplying divide technique, and it's based on wherever x winds up in the fraction. Okay? And then it's just, multiply and divide, right? 40 times 100 is 4,000. What's 4,000 divided by 30? 133.3 repeating. Good. And note, since this problem is not tied to money, you wouldn't round it to the hundredths or anything like that. You would want to give me the exact answer, right? And this is the perfectly nice exact answer. How else could you write that if you wanted to?
1/3.
Yeah, exactly. You could also say, or 133 and a third. Either way. And I'm happy with both answers. Again, as long as you don't write 133.3333333, because that's what your calculator said, right? Be smarter than just being able to copy your calculator, all right? If all you do is just copy your calculator, then you can be replaced by a computer, right? If you can do more than copy your calculator, then you can potentially not be replaced by a computer yet, all right? So just be careful, all right? And then, if you want to see this technique using the substitution, right? 40 equals 30%, 0.3 of times x. What do I do to get x by itself?
Just 0.3 and 40.
Yeah. Divide both sides by 0.3, and nicely enough, when you do 40 divided by 0.3, folks, what do you get? The same answer that you just got a second ago. All right? Either way, perfectly good. Huh? Okay. Now let's do another one. Let's do 50 is what percent of 20? Please make sure you read the question carefully before you start jumping to the answer. Okay? This is a sort of a traditional type of question because it's a setup that's meant to try and trick you. A lot of times they'll look at this and say, oh, well, I know that 20 is 40% of 50. This is just 40%. I'm done. That's if it's written the other way. Okay? So, start with the percent, folks. What do I put over the 100? X, right? Because I don't know what the percent is. Put X in there. What number follows the word of? 20, right? Make sure that that goes in the bottom of your fraction on the left-hand side. And then what number is associated with the word is? 50. Again, based on where x is, cross multiply and divide. $50 times 100 divided by 20. And when you punch all that out, what does your calculator spit back at you? And technically, what else should I write here, folks? Percent, because this problem is asking for what percent? 50 is 250% of 20. This is being based off of 20. So the fact that 50 is more than 20 means that this needs to be more than 100%. In fact, it's 2.5 times as much, hence 250% of the number. All right? Again, this is where reading carefully is important. All right? And then doing this, the translation technique, I like to do this one last, just so that it points out a specific potential pratfall to the translation technique. Right? 50 equals what percent? X times 20. So to get x by itself, divide by the 20. And what do you notice?
You get 2.5.
Uh-oh.
You've got to convert it to percent.
All right, good. This is the decimal representation of your percentage, folks. Remember that when we were dealing with percentages back up in the other problems, when we were doing translate, I always translated the percent to its decimal. So likewise, when you solve for the percent, you're going to get the answer in decimal. You need to convert that to its equivalent percent, okay?
Why did I divide it as
Numbers.
Again, though, you built the 100 into the fact that this is 20, and it's okay. It's right in there. But realize that only works when, what happens if this number had been like 0.3? Would you know to divide by 0.003? And if you do, then we're all good. Just be careful, okay?
Didn't you say for the translation method, though, we had to use it as the decimal, not the full number?
Yes,
So then would we automatically just get the 250%?
Would
Because if you used the decimal and divided by 0.2 instead.
right, but this is actually the real number 20, okay?
Oh, yeah.
And so the whole point is that when we get it back, it comes back as the decimal.
Yeah.
And then you just have to remember that if you're doing translation method, I always work with decimals. So if you want percent, you gotta make sure you convert. And again, whether you convert at this point or you convert up here somewhere, if you know where that works, I'm all happy. I tend to do it last, but that's just me. All right. So, are we not bad with one sentence percentages? You guys could do one of these if I threw one up there. Okay? So let me do one more then and make you guys do it. Alright? Let's go with 10 is 2 and let's go with 4/5% of what? Folks, I do love little percentages like 2 and 4/5, or worse yet, stuff like 0.1%, because those are very real numbers out there in the world right now, right? If you look at your checking or basic savings account at a bank, you're probably earning somewhere around 0.1% of interest, maybe even worse than that, maybe even like 0.05% of interest, and so you have to be able to work with percentages that are teeny tiny right now, right? So, how should I do this? Which way do you guys like better? Do you like the translation technique or do you like the is over of technique?
Translate.
Nothing like getting from both sides. Alright, so anyways, let's do it both ways then, alright? What am I going to do first using is over of? Well, first you write the fractions, right?
I need the percent and
2.8, good. So 2 and 4/5, folks, is 2.8. Note, In the is over of technique, just write the percentage number down. Right? What's next?
X
So where do I put that?
on the bottom,
On the bottom is my x,
and 10 on the top.
and 10 on the top.
Cross multiply 10 times 100 divided by 2.8.
10 times 100 divided by 2.8.
2800.
What was that?
2800.
That sounds like you multiplied by 2.8.
357, 14.
So what happens if I didn't tell you where to round this number? Just keep writing numbers down. Note, folks, there is a cool button on your calculators. If you look for it, it may be one of those buttons on the top of your calculator. It's up above the PRB button, F arrow arrow D. That's what's known as the fraction to decimal button. So if you hit the second key and then punch PRB and hit equals, what does your calculator spit back at?
357 and 1 7.
357 and 1/7. Otherwise, you'd have to write down the 0.142875, whatever that repeating decimal is, and figure out what the repeating decimal is. That would suck, right? Don't write repeating decimals if you can write a nice little simple 1/7 as a fraction. This number is way the hell better than that decimal that repeats over and over and over again. Okay, folks? So, use that button on your calculator to your advantage to convert decimals into fractions, or vice versa if you want to, right? The nice part about it is it goes both ways. And then if you wanted to do this using the conversion or the translate technique, 10 equals 0.028 times x. Again, 2.8% convert to a decimal correctly, 0.028. Divide by the 0.028, and yes, this is going to be the same number, 357 and the 7th. Alright? Alright, so those two techniques are the standard two techniques that you are shown for one sentence percentage problems. Now, the problem is that most of your percentage problems will not show up as simple one sentence percentages. They will be word problems. Alright? Let's see. So, Oscar Mayer has total sales of, let's say, 16, that's 16, I swear, $16.4 billion. Probably that's per week, be my guess. But let's suppose that it's a bigger number. Maybe it's just for a specific region. And then I tell you that 65% of all sales come from hot dogs.
You must really like hot dogs.
It's just lunchtime. What am I going to ask, folks? Well, I don't, nowhere do I talk about actual hot dogs other than the 65%. So, but what do I care about here? I'm looking about money, right, folks? So, what are Oscar Mayer's sales in hot dogs? So when you start getting word problems that are not just a straight one sentence thing where you can figure out what is and figure out what of is and figure out what percent is easily, you often have to deal with a slightly different type of problem. And now, what I propose, or again what the textbook tries to propose to some degree, is that this is a slightly different method to solve this with. And the method, and as you can guess, I kind of like this technique. It's known as the PBR technique. For those of you who are old enough to know what a good PBR is, what does P, B, and R stand for in a percentage problem, folks? P stands for the portion or the part. B stands for the base or the total, and R is the rate as a decimal. So it's very similar to the translate technique, folks. It's just that it's a little bit more formalized with these three terms: portion, base, and rate. And if you like, just so that you know, the way this works with is over of, portion is, base is of, the rate is always the percent. Okay? So when you get these types of word problems, you can, if you wish, instead look at it as a portion of the base type of problem, okay, or PBR. And if you want to think of it as a patched blue ribbon problem, that tends to be the way I think. Just, back when I was in college and I was umpiring Little League games, that used to be what we did after the game. In order to, you get paid in cash at the end of the games that you umpired, and we would drive over to the liquor store where they sold 30 packs of PBR for $5.99. If it was on special, it was $4.99.
Yeah.
And that was like a way to spend a good Wednesday afternoon in the summer back when I was an umpire during the evenings, right? So a little bit of PBR to spend the night away. Now, anyways, how are we going to solve this problem, folks? So you just need to, again, I'm going to have three things that I need to do, that I need to have. I'm going to give you two of them. Your job is to find the third. Okay? So given this problem, what did I give you? I gave you the B and I gave you the R, right? Why did I give you... Please remember the R is always the really easiest one, right? The rate is always the percent, okay? For the rest of this class, whenever you hear the word rate, your brain should think percentage, period, okay? So, in this case, you know that the rate, oops, I'm blue, is equal to 65%. And since it has to be as a decimal, what are you going to take 65% and convert it to? 0.65. The other thing I gave you was the base. What's the base, folks? $16.4 million, right? Because that's the total sales. And note, the reason why it's the total and not the portion is because I told you total sales, therefore it's the base. Whenever you're given the word total in there, that's a way of signifying base, right? And so in this case, I'm asking you for the portion. You don't know what it is, so it's X. And then you just throw those into the equation. P equals BR. X equals 16.4 million times 0.65. Now the question is, how are you going to do that multiplication? Note, folks, it is okay to use the number 16.4. Okay? So if you take out your calculators and do 16.4 times 0.65, what do you get?
10.66. But it's million.
Okay, good. Note, the millions carries with this problem. Okay? That is a perfectly good answer to this problem as long as you write the capital M. If you do not write the capital M after it, just say it's $10.66. That's obviously silly, right? And I will obviously mark it wrong, okay? Now, if you want to write it out in all of its glorious detail, so if you take 16,400,000 and multiply by 0.65 and get 10,660,000, both of these are correct answers, okay? Both of them are okay. I would like to think that you could handle either answer as well, okay? All right. Not bad? All right, so let's try a variation on the theme then. Let's see. Who's the chili maker on the highway? Hormel has, let's say they're not quite as big as Oscar Mayer, are they? Right? Suppose they have $1.25 million of sales in Chile. And again, this is like per week or per month or whatever it is for them. Chile is, let's say, 80% of total sales for Hormel. What am I going to ask for this time, folks? Yeah. What are total sales for Hormel? I have no idea what else Hormel makes, to be honest. Do they make anything else other than chili? I'd assume that they do, right? I assume that all their byproduct stuff turns into like a different type of food product, so everything that they can't convert into chili becomes like a hot dog. Are there actually like regular beans from Hormel? Canned beans? Okay, we'll have to try and work out a field trip to Hormel so we can. I don't know. Wouldn't that be cool? I'd go for that. Why not? Figure out what they make. All right. So, note, folks. Again, one of the things that this method allows you to do is to sort of compartmentalize what you're looking for. Right. Again, it sort of ties into the words. Right. Remember, P is portion, B is base or total. Right. R is the rate. So, what I like to tell students is that, remember, I am very liberal when it comes to giving partial credit on tests, right? So if you're not sure how to do this problem, but you write down P equals BR, because this is a P equals BR problem, you would already get 3 points out of 10. You did nothing on the problem. Nothing but write 3 letters and a symbol, and you got 30% of the problem, because that's half the battle is figuring out where to start, okay? You just keep earning more points the more things that you tell me. So how could you earn another point? Take the easiest road.
R is 80%.
R is 80%. And you would tell me that's the same as 0.8 or 0.80. Again, now you're at 4. And again, have you done anything? No. But you've at least gotten yourself to the point where you're just about passing. All right, what else? Now, here's the hard part, right? This is sort of the guts of this particular problem. Which one did I give you? P or B? I hear P and B. Which one? Why are you saying it's P? Rage.
Because it's just in Chile, you're asking for total sales.
Right. So here, it's actually easier to figure out what I'm asking for than it is to figure out what the 1.25 is. I mean, what's that last sentence ask for? Total sales. Therefore, what don't you know? The base. Therefore, B has to be X because I asked for total sales, and therefore I clearly did not give you 1.25 million as total sales. Right? This is one of those sort of process of elimination types of techniques to use when you're solving problems. Okay? So sometimes it's best to go through the whole problem to see what you got. So then, by default, now you say, hey, there's only one number left. That's got to be the portion. And then you think about it for a second and say, oh yeah, chili is only a portion of what they make because we now know they make canned beans, although honestly I didn't know that. And now we can take these three values, plug them into our variable, and say, hey, do the algebra to solve. Right? So 1.25 million equals 0.8x. What do I have to do to get x by itself? Divide by the 0.8. And what's 1.25 divided by 0.8? Somebody crank it out really fast.
1.5625.
And what do I have to put after that number? M, right? So $1.5625 million in total sales at the Hormel Corporation. And if you want to write that out as the full number, right? If you want to write it out as $1,562,500, that's perfectly fine. But both of those two numbers are exactly the same. All right? So I would like it if you guys could start getting more comfortable writing numbers in both formats, if at all possible. All right? Not too bad. All right, so let's see. Let's try another one. Here you go. I have 40 marbles left. A bunch of them have been rolling out my ears over the years, so I've only got 40 left. Let's see. Let's say that 17 of my marbles are red. And my question is, what percent of my marbles are not red? All right. So again, seeing this problem, and again, I'm going to show you more stuff to deal with things later so that you say, hey, this is a portion equals base times rate problem. Unfortunately, your freebie point, folks, the whole rate thing, unfortunately, what's the rate?
X.
Yeah, we don't know. Bummer. I'd probably still give you 4 if you did that, though. But now, what else is P and B? B is 40, P is 17, because the 17 of my marbles, hence I'm telling you a portion of my marbles are 17, thus the 17 is a part. And this one's a little bit more obvious just because when you're dealing with marbles, right, you know the larger number is going to be the base because that's got to be the total number, and the smaller numbers have to be a part of it. Do realize that that's not always the case, but it is with certain physical items. All right? So, now I can plug and chug, right? So, 17 equals 40 times x. Divide by 40, awesome.
0.425.
What was that?
0.425.
0.425. Remember that when you get the rate, folks, what does it show up as? The decimal form. So how do I convert that to a percent?
42.5%.
Awesome. What would I do with that answer if you gave it?
No, for everything.
Why would I mark it wrong?
Marbles, percent marbles are not red.
42.5%
That's
Other
red
ones
ones.
are not red.
are red.
Other ones.
This is red.
Oh.
Marbles are red. And I would still mark you wrong if you wrote that answer down, because what did the question ask for?
They aren't
Not
red.
red.
What percent are not red? So if 42.5% are red, what percent are not red?
57 is not red.
And how did you figure that out?
I minused it from 100.
Exactly. So you calculated the complement of 42.5, and the complement's whatever makes it add up to 100. This gives you what's not red. So note, folks, that yes, I appreciate the labeling, and in this case, labeling it points out to yourself that, oh, shucks, I'm giving you the wrong answer, right? Once you say that 42.5% of them are red, hopefully you'll go back to the question up above and see, oh crap, I asked for not red. Use your complement technique to get yourself how many are not, okay?
What would you screen down? I want to see the top one.
You just need the algebra or words too?
Just, P is 17, B is 40, okay.
Right. All right. So again, I like these sorts of questions where you deal with the opposite percentage. So does the homework, folks. Please watch out for that on the Chapter 6 homework, because it definitely tries to do that on a regular basis, right? Where it gives you one value and is really asking for the percent on the other side. Okay? So just don't forget your complements. All right. Not too bad? All right, so now you knew there had to be something more complicated, and there naturally is, right? And of course, we have to complicate matters by talking about percentage increases and percentage decreases instead of just dealing with straight percentage problems. Okay? So, again, a lot of this I'd like to think you have a relatively sound basis of working with already. And to show you that, I'm going to do a problem here, a write-up problem here that you guys can, I'd like to think, do right now. Right? So, let's suppose that I was making $50,000 a year. Whatever. Alright? And then let's suppose that I get let's make it even easy too, a 10% raise. And then I ask, what's my new salary? How do you do this problem, folks? Take 10%, make it a decimal, so 0.1.
Yeah, and then I times it by 50,000.
Multiply by 50,000.
You get 5,000, but then you have to add it back to the 50,000, so it's 55,000.
So you're getting a $5,000 raise, but you have to add that because it's a raise. It's on top of that number, so you take that 5,000, you add it onto the 50,000 and tell me I'm now making $55,000, okay? Now, what I'm going to do is to show you the algebra behind this, folks. I know it's going to be a little bit of overkill. Just bear with me, because once you see it and we get the next problem, you'll go, oh, thank God I know the algebra. It'll make the next problem easier to do. All right? So the key here is that my formula is like this. And I once had a student tell me that it would be really nice if you put the rate times old in parentheses so that we know we have to do that first. So you don't really need those parentheses in there. You guys should know by the order of operations that this comes first, but just to be safe, I'll put it there to be sure. All right? And note, folks, how many different things are in this equation? 3. Just like our PBR problem, just like our is over of equals percent problem, right? Everything is based off of essentially the same stuff. The only difference is that notice about old shows up twice, okay? You just have to be a little bit careful with that, all right? Now, based on my problem, what did I give you?
No, X is new.
X is new, right? We don't know what my new salary is, so it's X. What's my old? 50,000, because that's what I was earning last year, right? Therefore, it's old. And then what else did you get out of this, right? The freebie point, right? Remember that the rate is always the percentage, and remember to always convert the percentage into a decimal. And again, we can just substitute these sorts of things in, and you'll be doing exactly what we did just a second ago. We're not doing anything different here, folks. Again, it's just setting the table for the next problem, which is more complicated, all right? So here you're going to go, you're going to say, great, X equals 50,000 plus 0.1 times 50,000. .1 times the 50,000. Again, if you want to think of it like that, that's perfectly okay. There's your $5,000 raise. Add it to the 50,000. This gets you to 55,000. Okay, so that, I would like to think that if you all had a little bit of time, you could eventually get to that number without necessarily going through all the algebra crap. All right? But this next problem is where the algebra crap will come back to you. All right? So, let's suppose that I am making $72,000. This is after I get a 12% raise. What was my old salary? And this is where it starts to get a little bit more complicated, and where students make the standard mistakes that you make when you're dealing with percentages and percentage increases and percentage decreases. All right? Because technically, folks, what kind of a number am I looking for? A number that's lower than 72,000, right? And so when we're looking for a lower number, what do we normally do to get to a lower number? We subtract. Folks, if you subtract in this problem, you will always be wrong. Always. Always, always, always. Okay? This problem, because it says 12% raise, this is a percentage increase problem. If the word that is next to your percent is increase or raise or growth, it's a percentage increase problem. You cannot do this problem by taking 12% of 72,000 and subtracting. It does not work. It's always wrong. Okay? It's close-ish, but it's not close enough, and definitely not close enough for me, Mr. Exact Anal, retentive person, right? So you know that you can't do it wrong. All right? The key to this problem is that it is a percentage increase problem. And whenever you're dealing with a percentage increase problem, the formula is always the same. Okay? New is equal to old plus rate times old. And now, what did I give you in this problem? Yeah, I gave you new and rate. You got new is equal to the 72,000. The rate is 12%, again, 0.12. And so what is old? X. Awesome. And sorry I switched to blue. I'll switch back to black. And the cool thing about it is that you can take that and plug it right back into the equation. And what equation do I get then? I take 72,000 equals old. What is old? X. Plus rate times old, 0.12 times X. And before you tell me what the sum of those two things is, let me remind you, folks. What is X plus 2X? 3X. What is X plus 1/2 X?
1.
What's 1X plus 1/2 of an X? Yeah, 1.5 X's, right? So what is 1X plus 0.1X? 1.1X. Okay, good.
1.12x.
There you go. 72,000 equals 1.12x. Because you add 1, again, remember we don't write that 1 there, but it's really there. 1 plus 0.12. Remember that there's a whole decimal point, line the decimal points up. And so how are we going to get x here, folks? Divide. And here is the other way that you get smaller numbers other than subtracting. Okay, folks? Instead of getting a smaller number by subtracting, we are going to get a smaller number by dividing by a number greater than 1. And nicely enough, what is 72,000 divided by 1.12? 64,285
71 cents.
and 71 cents. Please round the pennies correctly. Since it's money, you know where to round this one at. Okay? All right? So note, folks, you do not get the answer by taking 12% of 72,000 and subtracting. Because you see the word raise, that means it's increase. All right? And that is a classic trick question. I can guarantee you 3 trillion% that there will be a problem like this on the next test, where you're going to be given a value that's the new value, and you need to get the old value, either being a % increase or a % decrease problem. Okay, folks? Just be ready. All right? All right, so not bad with percentage increases. Okay, so let's flip the coin. Let's suppose I was making $70,000, and then Governor Walker gave me a 6.5% pay cut. Welcome to being a teacher in the Wisconsin system. What's my new salary? So note here, the only difference, right, is that I changed the word that came with the percentage. Pay cut. This, therefore, is a % decrease problem. What's the difference between % decrease and % increase? Not add, but subtract, right? Because we're doing % decrease. So the basic formula, folks, for dealing with a % decrease is that your new is going to be your old minus the rate times your old. It's exactly the same formula, except that there's a minus instead of a plus. Okay, so it's nothing's changed. It's just subtract instead of add. Again, this is the sort of thing where you guys would probably know how to do this already, but just to be safe. So for this particular problem, what did I give you? Take a freebie, right? The rate, 6.5%. How do I write that as a decimal? .065, good, don't forget the leading zero. What else did I give you? The old, right? And so my new is what I'm looking for, x. And yeah, this is one where when you plug the numbers in, it's not as painful as you might think. 70,000 minus 0.065 times 70,000. And what's 0.065 times 70,000? Is that 4,550? And again, note folks, that represents my pay cut. That's the actual dollar amount that I had removed from my salary. So what am I down to after this pay cut? Down to $65,450 per year. Again, that's the straightforward problem, right? Where I've sort of given you the old and said step forward to the new. Now let's go backwards, right? So again, this is sort of very classic in this math class. We'll be doing it all semester. I'll be teaching you how to walk forwards, and then after we figure out how to walk forwards, we'll say, okay, folks, now walk back. That's going to happen for ever, right? So let's walk back, right? Let's see. Ooh, let me try. Let me give it to you in a slightly different wording this time too, so that it's not as easy to figure out, right? So let's suppose that I have. Let's suppose that I have 20% less money than we. I have, well, let's keep it relatively simple. Let's suppose that I have $60. How much does Leaf have? Again, when you start doing these word problems in this chapter, and folks, there are a ton of word problems in this chapter. This is the longest homework assignment you will have in the entire class, okay? 46 some odd problems, all right? One of the first things that I want you to do is to figure out what kind of a problem it is. Is it a straight percentage problem, P equals BR? Is it a percentage increase problem, or is it a percentage decrease problem? So in this particular problem, you will go to the percent sign and see the word less after it is less. 20% less, therefore, you will write down percent decrease. And as soon as you write the word percent decrease, or the phrase percent decrease, in your brain you will think, do not add. Okay? Just like you can't subtract with increases, you cannot add with decreases. You cannot take 20% of 60 and add it. That will be the wrong answer, period. Okay? You've got to do something else. So this is a percent decrease problem. And again, remember, you get a note card for this test. It wouldn't surprise me if people wrote these sorts of formulas down on the note card just to be safe. Again, I don't think you really need to because you should know these already. But if you want to write them down to be safe, hey, it's your note card. Do what you want. Right? Now, here's the hard part. What did I give you? Take the freebies first, right? Remember the rate. That one's always the same. It's a percent. So it's 20%. 0.2. Awesome. Now here's the hard part. Did I give you new or old? And there's no easy way to do this one because it isn't like you're figuring out how much did I have this year and how much did I have last year, or how much do I have this year and next year. It's a comparison of the two people. So, who has more money, folks? Leaf. This is a percentage decrease problem. Where do you start in a percentage decrease problem? Where do you start in a percentage decrease problem? If
That you have, or.
Yeah, in comparison, right? You always start at the higher number and wind up with the old number being smaller, right? Because you're decreasing from a higher number to a lower number. So I being $60, that's the lower number. That's where you end up. That's the new spot, right? In a percentage decrease problem, the old is larger, the new is smaller. So in this case, I am new.
What did you say, old is smaller?
For a percentage decrease
Right.
problem, old is larger,
Oh, larger.
new is smaller, right? Because you start old at the larger value and end at the new value smaller, because you're decreasing. Remember that those things are exactly the opposite when you're increasing, right? When you're increasing, the old is smaller and the new is larger, right? Because of course the ladder rotates, right? So in this case, old is X. And that's a little bit tricky because there isn't a time consideration in the words to give you which one's old and which one's new.
But if you do it the opposite way, then Leaf has less money, so it doesn't even make sense.
Exactly. And as long as you check afterwards, if you do it the wrong way, the numbers will work out wrong anyways, and you will know that all I have to do is flip those two. Because those are the only two numbers that can change, what's old and what's new. So if you do the problem and it doesn't work, the number you get doesn't give you a value that makes sense, flip the numbers, do it again, and you'll be like, oh, that makes sense, and boom, that's your result.
But 60 is a higher number, so why does it go in new? I thought you said old is larger than this.
Right, because we're dealing with percentage decrease. So our older value is larger, and our newer value is smaller.
Okay.
And the 60 is smaller, therefore it's new.
Okay.
Okay? So let's do the algebra once we substitute this in. So 60 is equal to old x minus 0.2x. And again, be careful, folks. What is x minus 0.2x? 0.8x. Good, because remember, again, you don't write it, but it's there. 1 minus 0.2. If you got to do it on your calculator, you can. I'd like to think you didn't have to. And so what do I do to get x by itself in this case? Divide by 0.8. And again, here's a new reality to math, folks. To get a larger number, instead of adding, you can divide by a number that's less than 1. Right? When you take 60 divided by 8, what do you wind up getting? $75. And the cool thing about it is, folks, that if you take 20% of 75, 15, what's 75 minus 15? Down to the $60 that I had. Okay? And note, if you did it the other way, if you made the 60 old, you'd get a totally weird number. You'd get something like, 48 for Leaf. And you'd say, wait, Leaf has to have a bigger number. I just am giving a smaller number. I screwed it up. Change the numbers, recalculate, bam. Okay? So again, the cool part about these problems is that if you're careful, when you do them incorrectly, if you go back to the problem and check and just make a complete check to say, is the value going the right way? If it is, you're right. If it's wrong, you did it backwards, rotate. Okay? That's right, Leaf, come on. It's all you, it happens, it's magic. That's the way math is. Alright, so, not too bad though? Okay, so, let's try another one. Alright, so my shirt used to cost $29.99. Now, it costs, let's go with $12. What am I going to ask?
What is the percent decrease?
What is percent decrease? Or what's the rate? All right, so again, what type of a problem is this? This was
Percentage decrease.
percentage decrease because it says what's the percentage decrease, right? So the cool thing about this, folks, is that we can continue to do our algebra. Note, folks, that I'm going to do this the long way, and the reason I'm doing it the long way is so that we get some algebra practice. But when we're done, I'm going to show you the shortcut way, and you're going to be like, oh, that's so much better, thank you. So you got to do it the long way a couple of times first, then you can find the shortcut, okay? All right, so what did I give you in this problem? Old and new. Which ones are which? Please make sure you do them right.
Old is $29.99.
Old is $29.99. New
New is $12.
is 12. And obviously this time, the rate is X. Okay? And again, please remember that the rate is going to come to you as a decimal. And just so that we have some directions, suppose I tell you to round to the 100th of a percent. Okay? I don't think this one works out nicely. No, it shouldn't. Okay, good. So you'll have to do some round. Alright. The cool thing about it is, here's the algebra. We can just take these numbers, throw them up in here, and all we have to do is solve for x. Alright? Cool. So, new 12 equals $29.99 minus $29.99x. I flipped the x in the $29.99 order, it doesn't matter. So what do I do first to get x by itself? Yes? Subtract the $29.99. Remember that this $29.99 is attached to the x. We can't do anything with it until it's alone, and then we divide by it. So here, we have to get rid of the $29.99 first. Remember, if I gave you this problem, 2x plus 1 equals 5, you're not going to divide by 2 first, right? You're going to subtract the 1 first. Same concept here. So we're going to subtract $29.99. This is why it's always good to review a little bit of algebra. And again, you get to use your calculator, so by all means, punch it out in your calculator, right? 12 minus $29.99. Just do it. It's, be safe. And what do you notice that you wind up getting?
Negative number.
A negative number. Should that make you a little nervous? Should make you a little nervous because percentages are not negative percentages, and money isn't negative. It's like, yeah. But why are we okay, folks? Yeah, because there's a minus sign in front of the x still, right? Minus 29.99x. So to get x by itself, what are we going to have to do? Divide by that negative, and what do the two negatives do? Cancel and become positive. Okay, that makes a little bit more sense, all right? So yeah, we got to finish the problem off dividing by negative $29.99. All right, so somebody punch that in your calculator and give me all of the digits, all of them.
5, 9, 9, 8, 6, 6, 6, 2, 2, another 2.
That's enough, probably. All right. So remember, what type of a number is this again?
Percent.
It's a percent, but right now it's in its decimal format, okay? So what I get a lot of times on tests, folks, is that students look up here and they say, oh, where should we round things to? They say hundredths. And so what they do is they immediately round this number. What does it round to in the hundredths? 0.60, right? And they'll tell me it's 60%. But 60%, folks, is rounded to the nearest 1%, right? I wanted you to go to the hundredths of a percent. Before you round, you must convert to a decimal, okay? So this bears writing in red. Convert to percent, then round. So if you are calculating a percent, folks, you are going to get the number as a decimal. Convert it to a percent first. 1, 2. That's what it is as a percent, right? This is really 59.9866622, and there's probably more numbers percent. Now round it to the nearest hundredth, and what does it round to? Yeah, not quite 60%, but pretty darn close. Okay? Rounded to the nearest hundredth of a percent. So just make sure when you're doing that rounding, you wait till after you convert if necessary. Alright? Alright, and one of the things that I would like you guys to do in addition is take a sanity check. This number is more than 50%. Therefore, what had to happen to the price of that item?
Gotta be double.
Yeah, it had to be at least cut in half, right? Because 50% means it's half. So, what was the price? Or $30. What's half of 30? 15. Is that more to get down to 12? Yes. Does it make sense that it's 60% then? Yes. Okay? Note, what I often get students doing on this problem because they've been shown that it works is they'll say, oh, you just divide the two numbers and you're done. If you take 12 and divide by 29.99, folks, you are going to get 0.411111, 0.4009 or something along those lines. And you're going to basically say that this is a 40% decrease. It always gives you the complement if you just divide the two numbers. If you don't remember to take the complement, you do it wrong. And invariably when you're in a test and you're nervous and you're in a hurry, you forget to do the complement and you wind up writing down 40%, and I just put a big old X through it and get mad at you. Please don't make that mistake, okay? Please do not just divide the two numbers. It does not work, okay? It just doesn't work.
Can't you do is over of?
You can do is over of, yeah, as long as you do the is over of with the difference between the two numbers. As long as you take the difference of the two numbers, works like a charm. But again, subtract and then do 17.99 of 29.99, and you'll get the 59.99. Okay? All right, now, you want the shortcut? I know we're almost out of time, so let me give you the shortcut to that one. If you just take the difference and divide by where you started, you will always get the decimal representation of your percentage change. Okay? So, note, folks, what is the difference between my two prices? What's $29.99 minus 12? $17.99. Where did I start? $29.99. If you take $17.99 and divide by $29.99, you'll get your 0.5998666662222222. That always works. And the cool part about it, folks, is that percentage change works for increase or decrease. Okay? this shortcut works for increase and decrease. Again, though, remember that you take the difference of the two numbers and divide by where you started. Do not just divide the two numbers. That doesn't work. Okay? So, really quickly, let's do a percentage increase problem, but just use the shortcut. Okay? Okay, so my shoes used to cost $62. Now they cost $85. What was the percent increase? Find percent increase. And again, let's say this time I tell you to round to tenths of a percent. So now you can use the shortcut as long as you do follow the rules, right? So my percentage change is going to be the difference of my numbers, right? And the cool part about it is that you can always subtract them so that you get a positive number. It'll always work, no matter what. All right? Where did I start, though, folks? 62. Please remember that when you're doing a percentage decrease, you start at the higher number. When you're doing percentage increase, you start at the lower number. So this is a straight calculation. What's 23 over 62? Give me a whole bunch of decimal points, folks.
3709677.
What am I going to do first? Convert it to a percentage. 1, 2. And then follow the directions. Round to the nearest tenth of a percent. So what is this to the nearest tenth? 37.1%. Alrighty? Excellent. You know what I'm going to tell you, folks? Two through 92, the evens. Yes, this is a rather painful homework assignment. Please start sooner than later. I will not be surprised if more of you take the full 1 week extension to get this homework done. We will go over it on Thursday, but it's not due until Tuesday of next week. Okay? So please do read through the problems, and if you have questions, remember you get your 3 freebies on Thursday. Turn it in on Tuesday. And remind me on Thursday to hand back the tests because I will finally have everybody taking them in the other class. Thanks, everybody.
Where's that, like, button that you flip from, like, the decimal to the fraction?
For this one, I think you might have to go into mode.
That's really complicated.
It's mildly annoying, yeah. Is this the one that oh no, this has the math on it. So never mind, clear that. There, fraction decimal.
Okay, so I just click that.
Yeah, so so if you type in something like 5.62, and then if you hit math fraction.
That's damn nice. Alright, perfect. Thank you.
Yep.
When are you going to have these notes online?
I put them online right now.
Did you?
Yeah, well, I mean, once I save them, put them upload.
Great.
Yeah. But note that the video usually takes a little bit longer.
No, I'm just